So y-axis, and then we have x-axis. X-axis or the vertical axis, we have the price, and on the horizontal axis we have the demand, right? Now, what will happen if the price is actually this much? If the price is this much, if the price is high, demand will be low. What will happen if you reduce the price from here to here? If you reduce the price, demand will increase, right? What will happen if you further reduce the price? If you further reduce the price, the demand will further increase. If you further reduce the price, demand will further increase, right? So by reducing the price, demand is changing. Now, if you want to draw a graph, it's going to look like this. Not very nice, but yes, it's looking all right. Right? Now, can you see that you can actually match all these crosses and you can see a trend here, right? Like with the reduction in the price, the demand is further increasing, right? Let's call this angle B. Let's call it B. What is B? B is the gradient or the angle, right? B is this angle, right? Okay, now, okay, if you further extend this line, it will touch this line. And if you further extend this line, it will touch this. Okay, at this point, can you guys tell me that how much is the demand at this point? How much is the demand at this point? Who's going to tell me the level of demand at this point? What do you think? What is the level of demand at this point? Zero, because demand is increasing from left to right. And at this point, demand is zero, right? So of course, if the price is very high, then the demand will be zero. So this price at which demand is zero, we'll call it A. So A is the price at which demand is zero. And what about this point, right? What is the demand at this point? This is the maximum demand, right? This is the maximum demand. But what is the price at this point? What is the price at this point? Price is zero, isn't it? Price is zero. You're at this point, so price is zero. So you can call this, this is the price at which demand is maximum. Remember this word maximum, please don't call it unlimited, right? Sometimes students call it unlimited. It's not unlimited, it's the maximum. Demand will be maximum, right? Now, this and this, these are the two extremes, right? This is when the price is zero, right? At zero price, price is equal to zero, price at which demand is maximum, right? And this is the maximum price at which demand is zero. And of course, we don't want to have these two extremes. We will avoid these two extremes. We don't want to increase the price so much that nobody wants to buy from us. And we don't want to reduce the price so much that everyone wants it, but then there is no benefit if you sell it, right? So the demand is in units, right? And what is the B? B is the gradient, right? B is the gradient. And we can call B as change in price divided by change in quantity. Please don't confuse this with the price elasticity of demand formula, right? This is the gradient, the change in the price by change in the quantity. What is A? A is the price at which demand is zero. It is so high that demand is zero, right? What about this point? This is the point at which demand is maximum, but price is zero, right? And that's actually the quantity, right? Now, why are we actually calculating this? Why are we calculating this, right? I'll tell you in a while, right? Can you see the formula for the demand equation is P is equal to A minus BQ. Let's write down the formula. P is equal to A minus BQ. This is the demand equation. This is the demand equation, right? Now, why is this important? First of all, A is not going to change because this is the price at which demand is zero. So we can easily find out the price at which nobody is going to buy from us, A. B is the angle, that is also not going to change. So what can change? The price and the quantity. Now, with this equation, if we know the value of A and B, then for a given price, we can calculate quantity. Right? Which means that, let's say, for example, if A and B are known, and let's say if P is also known, then we can calculate the quantity, like at this price, what should be the quantity that we should be producing, right? So it's actually relevant to the production department or the production manager. Right? Like, let's say, for example, the production department manager. Now he's saying, okay, A and B are known. And let's say the sales department manager tell you that, okay, the selling price will be 10, right? So now the production department manager can guess that what should be the quantity. Similarly, let's say if the production department manager is telling you that we will be producing 300 units, let's say, then what should be the price, right? So if, again, if we know the value of A and B, then for given quantity, we can calculate suitable selling price, right? And this will be relevant to the sales department, which means that if the sales department manager who also know the value of A and B, if the production department manager will give him the quantity, then he can choose a suitable selling price. So of course, if the quantity is too high, then he has to reduce the selling price. If you want to sell more quantity, he has to reduce the selling price, right? You getting my point, right? Is this point clear, everyone? So now let's see a question so that it makes more sense. Let's see a question on this, right? We'll ignore this right now. We can ignore this formula. We can see example over here, right? We'll call it example 1, right? Because there is another example on the same page. So we'll call the second example example 2. This page number 30, example number 1, right? So what is the example? What is the question? The current price of the product is 12, right? So let's call it price. So let's call it um, P1, right? This is the price. So let's call it P1. Now, at this price, the company sell quantity of 60. Let's call it Q1. 1 month, the company decided to raise the price to 15. So let's call it P2, the second price. But only 45 items were sold. So at the price of 15, we can sell 45. So at this price, we can sell this quantity. At this price, we can sell this quantity, right? Okay. Now, determine the demand equation in which it is assumed to be a straight line, right? It's a straight line equation, and you can ignore the last line, right? So how do you solve it? How do you solve it, right? First of all, you need to know that this is the price, this is the quantity. And then when this is the price, this is the quantity. What's the formula for B? Can you guys calculate B for me? What's the formula for B? Can you guys calculate B for me, please? Right? The formula for B is a change in the price by change in the quantity. So what's the value of B? Can you find out the value of B for me, please? Okay, let's do it together. So example number 1. What do you do first? First of all, step 1, find B. Now we know that B is equal to change in the price divided by change in the quantity. So what is the change in the price? Change in the price, not the percentage change divided by change in the quantity. So what is the change in the price? The price has changed from 12 to 15. So we'll say 15 minus 12. Just to avoid the negative sign, we are going to write 15 minus 12 instead of 12 minus 15, right? And then change in the quantity. The quantity change from 45, from 60 to 45. So that will be 3 divided by 15, which should give us 0.2. So the value of B is 0.2. Now, once you have the value of B, step number 2, using value of B in any equation, find value of A. Remember, A is the price at which demand is 0. Using any equation. Now, what is the demand equation? P is equal to A minus BQ. We know the value of B. Let's assume that the price and the quantity, any set of price and quantity. Now, if you see here, if the price is 12, the quantity is 60. So you can use this price and this quantity, or alternatively, you can use this price and this quantity. So I'll actually do one of them and then I'll give you time to try the other one, right? So let's say, for example, P, and let's say we choose the price to be 12, A, B is 0.2, multiply by the quantity, and the quantity at 12 price is 60. Right, so always bracket first. So what do you get? 60 multiplied by 0.2, which is 12. 12 is minus 12. When it will move to the other side of the equation, it will become plus 12 and added with this 12. So A will be 24, right? Now, you can use actually the other set. You don't have to do both of them. You have to choose one of them, right? If you choose the other set of information, for example, when the price was 15, A, B minus B is 0.2, multiply by the quantity. At this price, the quantity was 45. So can you calculate the value of A for me, please? Right? It should be 24. Can you give it a try? It should be 24. So first of all, find the value of B. Using the value of B in any set of information like price and quantity, this one or this one, right? You can get the value of A. Now, once you have the value of A also, and once you have the value of B also, then what do you do next? Then you write the demand equation. So step 3, demand equation. Derive demand equation. Derive demand equation, which is P is equal to A minus BQ. So for example, P, which is equal to A, now we can write the price, which is 24, B, which is 0.2, multiply by the quantity, right? Now you must be thinking, well, what about this price and quantity, right? Well, we have already used the price and quantity above. No, they were just different information. I mean, it can be, I mean, if the price is changing, quantity will be changing, right? Now, this is the equation that we were talking about, here, that if we know the value of A and B, then for a given quantity, we can find out a suitable selling price, and for a given selling price, we can find the quantity that we should be selling, right? So I'll give you an example, right? So for example, if production manager, now how do you use it? If production manager wants to produce 100 units, what should be the selling price? Right? Now, of course, like if the production manager wants to produce 100 units, the sales manager has to sell 100 units, right? So what should be the selling price? So you can say P is equal to A, which is 24 minus 0.2 multiply by, instead of quantity, we're going to write 100. So what should be the suitable selling price? Can you find me the suitable selling price? What should be the price? What do you think? Anyone? Can you give me a suitable selling price? Is it 4? Thank you very much. If you want to sell 100 units, this should be the price. Now, what do you think? If the units produced are increasing, then the price will be reducing. So let's say, for example, if you produce less, then what should be the selling price? So if production manager wants to produce 50 units, right? It's for you. What should be the selling price? Anyone? Can you find out the suitable selling price? I'll also do the calculation. Try to do it before me. It should be 14. It should be 14. So you see, when you are selling less, then you can sell it expensive also, right? We can sell at $14, 50 units, right? Now, in the same way, we can do the opposite. Let's say, for example, if the sales manager is telling that the price should be, let's say, $6. If sales manager wants to sell at, let's say, $8, then how many units should we produce? So again, we are going to write the same equation, right? The sales manager, right? So this time the sale manager is wants to sell at $8. So the price is $8 is equal to A, which is 24, B, which is 0.2. What should be the quantity that we should be selling? Can you find the quantity for me, please? Right? Can you find the quantity for me, please? Are you getting 80 units, right? So at this price, the production manager should produce 80 units, right? Useful, isn't it? Okay, right? You see, when this is going to move to the other side of the equation, you're going to have negative on this side, and you'll already have negative on this side. Negative and negative will be cancelled out, and you'll have positive units. Now, I'll give you a question to do, right? Um, okay, sales manager wants to sell at $30. How many units should we produce? Right? Sales manager wants to sell at a price of $30. Right? How many units should we produce? So again, P is equal to A minus BQ. Right? We want to find the quantity. So price will be 30, A is 24, B is 0.2, multiply by the quantity. So what should be the quantity? Anyone? What should be the quantity? Okay, if you calculate it, you're going to get 30 minus 24, which is 6, and then you'll have negative sign on this side, and you will be dividing it by 0.2. So you divide it by minus 0.2, right? And you'll get a negative answer, minus 30 units. Do you know why are you getting minus 30 units? You know why are you getting minus 30 units? Well, minus 30 units, of course, this is wrong. You know why? Why? No, because the price is actually more than the maximum price. The price at which demand will be zero is 24. We said the price at which demand is going to be zero is 24. Now, if you want to further increase in the price, if you want to further increase in the price, can you see? If you further increase in the price, the demand will go negative. The demand will go negative, right? And there is no negative demand. So that means that this is not possible, right? This is not possible. So that means that we can't increase price more than A. More than A, right? We can't increase price more than A. That's the maximum price at which demand will be zero. So if you are further increasing it, demand will be negative. Well, there is nothing like negative demand, but of course, like you can't do it, right? Similarly, we said here, I said that never call it unlimited, right? This is not unlimited. This is the maximum, right? When the price is zero, then the demand will be maximum. So let's say, for example, let's say find maximum demand, right? Find maximum demand. So what's the equation? P is equal to A minus BQ. And at maximum demand will be possible if the price is zero. So when the price is zero, A is 24, B is zero point 0.2, find the value of Q. What is the maximum demand? Can you find me the maximum demand? The maximum demand. Are you all getting 120? The maximum demand, right? This is the maximum demand. So if I, let's say, for example, tell you that production manager wants to produce 150 units. Find suitable selling price to sell 150 units, right? Can you find suitable selling price? P is equal to A, which is 24, minus B, which is 0 0.2, multiplied by Q. We want to sell 150. So what should be the selling price? Can you find me the selling price? Minus 6, isn't it? Minus 6. Why are you getting minus 6? Because you want to sell more than the maximum, which was 120. So of course you cannot sell more than 120. So you cannot have a demand more than 120, and similarly you cannot have a price less than 1, right? Or you cannot sell negative units, right? So you cannot increase the price more than A, right? Okay, that's the price. That's the demand equation. That's the demand equation, right? So one way of doing it, the way we have done it here, in step 1, we said find B, and using the value of B, we can find the value of A by putting any price and quantity in the equation, right? That's what we have done. But there is another way of doing it also, right? And when I tell you that there is another way of doing something, please don't think that you have to just consider one method. You have to consider both the methods, because your question can be tested in different ways. You can also find the value of A directly, right? Rather than substituting the figures in the equation, you can find it directly also, right? What is the formula? A is your current price plus bracket current quantity divided by the change in the quantity multiplied by the change in the price. Now we know that our current price is 12. We know that our current quantity at this price is 60. How much is the change in the quantity? It is increased from 50 to 60. So the change is 15. How much is the change in the price? Change from 12 to 15. So the change in the price is 3. Now, if you want to calculate that, you should get 24 once again. Would you like to give it a go? Give it a try. You should get 24. Let me know when you get 24. So yes, that's what you get. So bracket first, 60 divided by 15. After that, the multiplication, so you multiplied with 3. And after that, the addition, so you add 12, right? Which will give you 24. Right? Always bracket first, then addition and bracket first, then multiplication and the division, and after that addition and subtraction. Right? So the demand equation, and the demand equation is actually very useful again to choose a suitable selling price. But yes, it could be also used by the production department, that what should be the number of units that they should be producing. Right? Okay. Now, The rational aim of a business is normally to maximize your profitability, right? You want to maximize your profitability, right? How do you maximize your profit? How do you maximize your profit? Like, what should be the quantity which will maximize your profit, or what should be the selling price which will maximize your profit, right? So, selling price and quantity which will maximize profits, right? Now, for this, I'll actually give you an example, right? We'll start with an example, and the example will be from the tree of apples, right? So we have different apples, right? One apple is here, the second apple is over here, right? The third apple is, let's say, over here. The fourth apple is over here, and the fifth apple is over here, right? So we have 5 apples on the tree, right? Now we know that the apple that we are selling in the market, the price is the price for apple 1, 2, 3, 4, or 5. The price is $1. We can sell it for $1, but the variable cost is different. So apple number 1, we can sell it for $1, and it is quite lower. So of course, it's very easy to pick it from the tree. So the cost is not going to be very high. Let's say the cost is half a dollar. So what will be the profit, right? So the price that we can sell this apple for is $1, and the variable cost of this apple is half a dollar. So the profit will be half a dollar. What about the second apple? We can still sell the second apple for $1, but because it's slightly uppish, so the cost will be slightly high to pick it from the tree. So how much will be the profit? $0.3. Let's talk about the third apple. The price is still $1, but it's still further higher. So the cost will further increase. So we'll say, let's say, for example, it is $0.9. So how much will be the profit? $0.1. The fourth apple is further high. It's difficult for us to pluck it from the tree. We can sell it for $1, but the cost to pick it from the tree will be $1. So how much will be the profit? The fifth apple, we can sell it for $1, but it's very high in the tree, and it's very difficult for us to pick it from the tree. So let's say its cost is $1.50 in order to pick it from the tree. So what will be the profit now? It will be a loss of half a dollar, right? So what do you think? Are you going to pick this apple from the tree or not? What do you think? Are you going to pick this apple from the tree or not? No, you are not going to pick it from the tree. You are going to let it rot in the tree, right? What should be you are going to stop at this point. This is the point when you're going to stop. You don't want anything more than this, right? At this point, you are going to stop. Selling anything more than this will not actually give you the profit, right? That means that the point at which your profit will be maximum, the point at which your profit will be maximum is when your price, the marginal cost is equal to the marginal revenue. Marginal revenue and marginal cost. So the revenue from selling one more item is equal to the cost of selling one more item, right? So marginal revenue will be equal to